Welcome back to All This Math. This is Professor Parker. If you're here, hit the like button. Also, if you have not subscribed already, hit the subscribe button. If you have any questions about anything that I'm about to explain as I'm explaining it, please put your questions in the comment section. If you got comments, put your comments in the comment section. All right. And then share this video with at least 2 people. All right. As I always say, share this video with at least 2 people. Share the wealth. All right. Now, I got my George Washington Carver sweatshirt on. Right? Make sure you're familiar with George Washington Carver, right? Don't just know that, he did work with peanuts, right? He did a lot more than that. He did work with soybeans, understand why he was working with peanuts and soybeans. Also understanding he was down at Tuskegee University in Tuskegee, Alabama, down there with Booker T. Washington. Make sure you are familiar with Booker T. Washington and a lot of the work that he did in terms of institution building. All right. So shout out to the ancestor, George Washington Carver. All right, now, what are we doing? We are going to simplify this expression, and we're going to use exponent rules. Now, I have a whole playlist on exponent rules. All right, so if you're watching this video, that means you're probably not in that playlist. Or if you want to see more videos and more examples dealing with exponent rules, then all you got to do is peruse through that playlist. So what do we have here? We have a fraction, right? That's a fraction bar. We got a fraction. We got 7xy times 6xy in our numerator. In our denominator, we have 21x to the third, y to the fourth. All right. So there are different ways that we could do this. Now that we could start this, what I would probably do is I would probably simplify the numerator. That's like my instinct. My instinct is to simplify the numerator. Now, if you wanted to, you could divide the 7xy with the 21x to the third, y to the fourth if you wanted to, or you could divide the 6xy by the 21x to the third, y to the fourth. You have options, right? In algebra, we have options. Now, my option that I'm going to exercise is I'm going to simplify this numerator by multiplying those 2 expressions together. Meaning this, I'm going to do 7 times 6, right? First, you multiply the coefficients. The 7 and the 6 are called coefficients. They are numbers that are adjacent to the variable terms. That tells us how many of those variable terms we have. Meaning this, think of xy as a thing, right? How many of those things do we have? We got 7 of them. Think of xy over here as a thing. How many of those things do we have? We got 6 of them. Down here, think of x cubed y to the fourth as a thing. How many of those things do we have? We got 21 of them. All right. So when we're doing multiplication or division, we multiply or divide the coefficients first. So what's 7 times 6? Make sure you don't need a calculator to get that. Make sure you know 7 times 6 from memory is 42. That's important. Make sure that you have your multiplication facts memorized. Make sure you do that. So 7 times 6 is 42. All right. Now we dealt with the 7 and the 6. Now we're going to deal with the x's. We match up the variables. So we're not doing x plus x. We're doing x times x. Now let me back up. How do I know I'm supposed to multiply 7 times 6 in the first place? Because there is no operator symbol in between these parentheses. When the parentheses are adjacent to each other, adjacent means next to. When they're next to each other, that means that you have to multiply this expression by the expression next to it. So that means that the 7 gets multiplied by the 6, the x gets multiplied by the x, and the y gets multiplied by the y. Now, back to exponent rules. What is x times x? When you have x times x, you have to take the base, which is x, the base is x, and add their exponents. The exponents are 1 and 1. What's 1 plus 1? 2. So you end up with x squared, right? And then you do the same thing with the y's. You match the y's up. You do y times y. Y times y, you write the base 1 time. You write the y 1 time. And what do you do with the exponents? You add them together. So this invisible, another thing you need to understand is that when you see a variable and there's no exponent written, understand that it's understood the exponent is a 1. Understand that it's understood the exponent is a 1. So x is the same thing as x to the first. Y is the same thing as y to the first. X again, x to the first. Y again, y to the first. Right? Now here, x already has an exponent 3 and y has an exponent 4. But if there's no exponent written, understand that there's an invisible 1 that if you need to write it, go ahead and write it. All right. Now, why is this x squared again? Because x times x, according to the exponent rules, we write the base 1 time, x is the base, and we add the exponents. 1 plus 1 is 2. So that means we have x to the second power. Then we do the same thing with the y's. We got y times y. We do 1 plus 1. Not 1 times 1. Not 1 times 1. 1 plus 1. which is y squared. Now, we've simplified the numerator. Now we go down here, we rewrite the denominator, 21, x cubed y to the fourth. Now, what can I do here? These are coefficients, 42 and 21. I can divide them. They're coefficients. I can divide them. I can do 42 divided by 21. Now, because I'm mathematically fluent, I know that 21 times 2 is 42. So therefore, 42 divided by 21 equals 2. So that means that basically what I'm saying is that 21 and 42 have a common factor of 21. So I could say 21 divided by 21 is 1, and 42 divided by 21 is 2, right? And then up here, now we're using the division property of exponents. The division property of exponents. We already used the multiplication property of exponents. Now we're using the division property of exponents. What's x squared divided by x to the third? When we're dividing the variables, and they should match up, the x's with the x's and the y's with the y's. When we're dividing the variables, we subtract the exponents. When we multiply the variables, we add the exponents. When we divide the variables, we subtract the exponents. And we subtract top down, not bottom up. Top down, 2 minus 3. 2 minus 3. So it will look like this. Let me write. So the 42 already turned into a 2. And we know why that happened. And now we're going to have x. We keep the base, right, in the numerator. So we got an x squared and an x to the third. We keep the base in the numerator. So then we're going to have 2 minus 3, right? And then we're going to have y. So we got a y and a y and a y. Then we're going to have 2 minus 4. So we got 2x to the 2 minus 3 times y to the 2 minus 4, right? And then in our denominator, we have nothing. Why? Because there was a 1 in the denominator. What happened to the x's? What happened to this x? Well, when you use the division property of exponents, you only write the variable one time, and you write it in the numerator. And this can be considered the numerator since there's no denominator, right? What happened to the y to the fourth that was down here, right? What happened to it? Well, you write the variable one time in the numerator. And like I said, this represents the numerator. All right. I mean, if you want to, you could put the fraction bar and then put the 1 underneath. That's not going to change nothing, right? You're going to end up simplifying and getting rid of the one in the denominator later anyway. So now it's time to actually subtract the exponents. So we got to know how to do subtraction of positive and negative numbers. We need to know that 2 minus 3 is negative 1. You need to know that without using a calculator. 2 minus 3 is negative 1. So you got 2x to the negative 1. And then we got y to the negative 2. So 2x to the negative 1, y to the negative 2. Now, we're not done. Now, how do you know when you're done? When you're done when all of your coefficients are simplified as much as possible. There are no coefficients to multiply by each other, and all of the exponent properties have been utilized, right? Now here, we're not done. How do I know we're not done? Because we do not want to have negative exponents in our final answer. We do not want to have negative exponents in our final answer. We got a negative 1 exponent and a negative 2 exponent. So how do we alleviate that? We alleviate that by using what's called the negative exponent property. The negative exponent property. Now, what does that say? That says that anytime you have a negative exponent, you want to convert the exponent to a positive, you need to take the base, stay with me, and move it to the other part of the fraction. Take the base and move it to the other part of a fraction. The fraction only has 2 parts, a top and a bottom, a numerator and a denominator, a top and a bottom, a numerator and a denominator. Think about this as consider this the numerator. Consider this the numerator. So in order to make this negative 1 become a positive 1, we're going to move this x to the denominator. In order to make this negative 2 become a positive 2, we're going to move this y to the denominator. And then the exponent goes with it and becomes positive. So now let me make this look like a fraction first. All right, so now we are going to make it look like a fraction, right? Because we're using the negative exponent rule. If we wasn't using the negative exponent rule, wouldn't be no point to do this. All right, so I'm gonna make that look like a fraction. Boom, put a 1 underneath. Just like how you make a whole number become a fraction. Just put a 1 underneath. Give it a 1 for a denominator. All right, now the 2 is not going nowhere because the 2 don't got a negative exponent. You only move the things that have negative exponents. You only move the things that have negative exponents. This x is going to move, and this y is going to move. The x is going to go to the other part of the fraction. Remember, A fraction has two parts, a numerator and a denominator. A numerator and a denominator. If the term is in the numerator, it goes to the denominator. If the term was already in the denominator, it will go up to the numerator. It will go upstairs. It's either going to go downstairs or it's going to go upstairs. Go downstairs or it's going to go upstairs. So this x to the negative 1 is going downstairs. This y to the negative 2 is going downstairs. Now what are we left with? We're left with a 2 in the numerator. The 2 is up top. Now this 1 is not really necessary. Once the x and the y go down there, it's not necessary, right? So we're going to have x, y squared. Now, let me explain this. What happened to the negative 1? Where'd it go? Where'd it go? Well, when we use the negative exponent rule, when the base or the term moves, the exponent becomes positive. The exponent becomes positive. So if I got x to the first power, I don't need to write it. Just like in this original problem. We originally had 7xy. These exponents were not written. I added them so you could visualize and see what the exponents were. But when our exponent is a 1, we do not need to write it. When our exponent is a 1, we do not need to write it. That's why when this moved down, it became x to the positive 1 power. But we don't need to write that 1. When this moved down, however, if your exponent is a 2, you need to write it. If your exponent is a 3, you need to write it. If your exponent is a 4, you need to write it. But if your exponent is a 1, you don't need to write it. Remember, I wrote those in earlier in the problem just so you could visualize, right? When we were using the multiplication property for exponents. So now also another question you might have is what happened to the 1? Well, the 1 is still there. What happens when 1 is your coefficient? Do you need to write it? No, you don't need to write 1. When 1 is your coefficient, you don't need to write it. When 1 is your exponent, you don't need to write it. When 1 is your denominator, you don't need to write it. That's part of understanding the language of math. That's part of understanding the language of math, which we all should learn and understand, right? And it takes practice. Now, how is this going to help you in life? Well, this whole process that we did just now, using rules, thinking about which rules to use in which situation and when and how, we are practicing using critical thinking skills. Thinking skills are important. We are, as grown men and women, even as children and teenagers, you need to know how to think. You need to know how to use your brain. Unfortunately, a lot of people do not know how to use their brain. That's why they be out here doing dumb stuff, right? So mathematics, algebra, geometry, pre-cal, all that. I know a lot of people sit around talking about why I need to learn this. I'm never going to use this in life. Yeah, you will use critical thinking if you have it. If you don't have it, you can't use it. And if you don't have it and you can't use it, somebody else that do got it, they're going to take advantage of you. They're going to see you coming a mile away. They're going to take advantage of you because they got critical thinking ability and you don't. So you're going to lose. Math is one of the best subjects for practicing using critical thinking ability. So to anybody that watches this and be thinking like, why I need to know this? How is this going to help me? You're practicing using thinking skills. You're practicing using critical thinking. It doesn't matter that you could take your phone out. Of course, you could take your phone out and go to PhotoMath or one of these other apps and cheat, basically. Or you could just ask ChatGPT what the answer is. But when you do that, you never get the opportunity to practice thinking and use your brain. And if you don't practice using your brain, you won't know how to use your brain. And then you end up in situations feeling stupid and taken advantage of, and you ain't even going to know it initially. You might not find out till months later. So take advantage of the opportunity to learn math, as much math as possible, because this is how you practice critical thinking, which leads to problem solving ability. Because we are human beings, we will have problems. Inevitably, we're going to have problems. Now, some people will be able to work to solve their problems. Some people will not be able to work to solve their problems. You ask yourself which group you want to be in. All right. So now, like I said, shout out to the ancestor, George Washington Carver. Study his work. Study Tuskegee University. Study Booker T. Washington, who's the founding president of Tuskegee University. Also study Hampton University, where Booker T. Washington attended as an undergrad, when it used to be a Hampton Institute up in Hampton, Virginia. All right. Just study historically Black colleges in general. Right. There's no shortage of ideas and events and institutions for us to study. All right. And if you didn't already, hit the like button. If you didn't subscribe already, hit the subscribe button. If you still got questions, that's cool. Put your questions in the comment section. If you got comments, put your comments in the comment section and share this video with at least how many? Two people. All right. See y'all on the next video. Peace.